Every star you can see, every planet we've mapped, and every atom in your own body belong to a tiny minority. Collectively, all visible matter accounts for exactly 5% of the universe. The other 95% consists of two invisible entities. One is the builder, a gravitational skeleton that holds reality together. The other is a destroyer, a pressure that is actively pushing the universe apart. In January 2026, researchers published the most comprehensive map of this hidden builder to date, using data from the James Webb Space Telescope to locate nearly 800,000 galaxies. It reveals a structure that determines exactly where stars can form, yet the substance itself remains completely undetectable. This map provides the sharpest look yet at the universe's invisible scaffolding, and in doing so, it precisely defines the boundary of what we still cannot explain. We call the builder dark matter. It doesn't emit, absorb, or reflect light, making it invisible at every wavelength we can measure. It isn't a black hole or a form of antimatter. It is a substance that interacts through one primary channel, gravity. We found it by watching galaxies move. In the 1970s, Vera Rubin measured the rotation of spiral galaxies and discovered a massive discrepancy. Physics suggests that stars at the outer edges should orbit slower than stars at the center, but Rubin found they orbit at almost the same speed. This chart compares expected physics to what we actually observe. For outer stars to stay in orbit at such high speeds, there must be missing mass, an invisible halo providing the extra grip required. We also see this mass through gravitational lensing. Because dark matter has mass, it warps the space around it. Light from a distant object passes through warped space, bending like a lens, mapping the invisible material. Dark matter remains a ghost to our sensors, but we can see the gravitational footprint it leaves behind on the visible stars. While dark matter pulls things together, an opposing force discovered in 1998 is doing the opposite. Dark energy is the substance driving the expansion of the universe to accelerate, pushing galaxies away from each other at an ever-increasing rate. It appears to be an intrinsic property of space itself. As the universe expands and creates more empty volume, the total amount of dark energy grows, making the expansion even faster. Einstein called this the cosmological constant. However, modern quantum field theory predicts a vacuum energy density that is 10 to the power of 120 times larger than what we actually see. It is the largest gap between theory and observation in the history of physics. New data from 2025 suggests the situation may be even more complex. Observations from the Dark Energy Spectrographic Instrument indicate that dark energy might not be a constant value at all, but a dynamic field that changes its strength over billions of years. If dark energy grows stronger, it could eventually overcome all other forces, tearing apart galaxies and even atoms in a scenario called the Big Rip. If it weakens, gravity could eventually win, pulling the universe back into a big crunch. Dark energy acts as the demolition engine of our reality, and the final fate of every star depends on the behavior of a force we cannot directly detect. To understand how these forces shaped the early universe, we have to look back at the very first structures ever formed. But the James Webb Space Telescope is finding data that challenges our existing models. Webb has identified massive, elongated galaxies existing far earlier in time than our theories allow. Ordinary matter should not have had enough time to assemble these structures so shortly after the Big Bang. This has led to the dark star hypothesis. These wouldn't be stars as we know them, but supermassive clouds of hydrogen fueled by dark matter particles annihilating each other at their center. If dark matter is made of weakly interacting massive particles, their self-destruction could release enough heat to support these massive clouds against gravity, allowing them to grow far larger and brighter than any star powered by fusion. Very first light in the universe was fueled by dark matter annihilation rather than the nuclear fusion we've long assumed. We are beginning to see the scale of this influence. The 2026 JWST map took 255 hours of observation to chart how dark matter is distributed across a patch of sky 2.5 times the size of the full moon. It shows the cosmic web. Vast filaments of dark matter, hundreds of millions of light years long, acting as a gravitational blueprint. Ordinary matter followed the gravity. Gas and dust flowed along invisible roads, pooling at intersections to spark the galaxy clusters we see today. This means your existence is tied to this architecture. The atoms in your body were created in stars that only formed because dark matter provided the foundation for galaxies to assemble in the first place. We have built a world and a history out of the 5% of the universe we can see, while the remaining 95% continues to move us toward a fate we are only